Check. Right, welcome everyone. Thanks for coming in. My name is Ewald Verhoeven. I am a test automation engineer from the Netherlands. So I might actually be the only non-developer here. Oh, there's another one. Okay, great. I'm not alone. Thank you. Feels so good. Hi guys, welcome. Please take your seats. Before we get started, I want to tell you a little story, and it's about flow. Are you familiar with the concept of flow in Lean? Yeah, some of you are. Okay, I'll tell you a bit of a story. About 3 weeks ago, I was traveling to this conference in Porto to deliver a talk on testing, since I'm the test automation guy, and I was traveling with my wife, and we were traveling from Düsseldorf International Airport in Germany. So that's really close to where I live. I live on the border between Germany and the Netherlands. And we were traveling there, and I'm always early. They say for a European flight you need to be 2 hours early, unlike most of these people, 2 hours early at the gate, or at the airport at least. So I was there more than 2 hours early actually. We were parking the car, moving to the terminal. We had no luggage to check in because we only had carry-ons and stuff. So, welcome. So, we were rushing through security. I'd like to get there early, as I said before. We were rushing through security. There wasn't a massive queue. There were no lines, so it was really, really easy. And when we get almost to our gate, we look at the time, oh, wait, we've got like 90 minutes, like 1 hour and a half left until the plane takes off. So it was, I don't know what time it was, but I think it was around lunchtime. So we decide to go to the restaurant, all right? There's plenty of time, let's go to the restaurant. So we grab something to eat, and about half an hour before our flight leaves, we think it's time to get up, get up to go to the gate and stand in line. Actually, I don't like to stand in line, so I wait to the very last second. And so we get up, and this is, when we walk to the gate, I realized this is not a normal gate, what you expect, where the airplane is standing at the gate and you can just walk into and board the plane. Now this is down. You have to go through the stairs and another back room and another hall, and then there is this gate, which is like a very small room. It's like 25% of this entire room, and there's about 200 people on this plane. So you do the math, and once we are walking in the hall, I hear someone saying over the intercom, well, please, passenger Ewald Verhoeven, come to the gate. This is final call. And I was like, whoa, that never happened to me before. So I rushed to the gate. I had my boarding pass and passport ready. So I scanned the boarding pass. And this lady from the airline company, she's like very annoyed with me. I can see that from her face. Like, I don't speak a lot of German, to be honest, but I hear her say something, "Sie sind zu spät." And that means you are late, So we were scanning it, and we move into the shuttle bus. And now I understand suddenly why they wanted to board us early is because we need to go to the shuttle bus, and that one is going to take us to the plane. So we rush in the shuttle bus, and the shuttle bus just sits there. It still waited for another 5 minutes. So I was like, okay, no, we are actually perfectly on time. And all the other passengers were like, not so happy with us, because they had the feeling they had to wait for us. But from my perspective, this is what we call flow. I didn't have to wait anywhere. I wasn't in that really small room with 200 people, like sweating and getting really uncomfortable. And then once it's time to board, everyone got to stand in line, and then still you have to wait, but now you have to wait standing up. So I didn't have to do any of that. So I was actually quite happy with myself. And unlike the woman from the airline company, but she only cared about one step of the process. Her job was to get everyone in the shuttle bus. When you deal with processes, whether it's software delivery or something else, there's usually a lot of steps in those processes. And in between those steps, you have sometimes a very long, or preferably short, if you ask me, period for waiting. And so I thought, I did a perfect job actually, but I was trying to emphasize flow. I was trying to improve the flow of passengers in this case. And that's what this talk is about. It's about flow, it's about how we can speed up things and not wait for stuff. So if you ask why your team is slowing down, this is the answer to the talk. It's flow. Probably lack of flow. But let's get to it. First, I want to ask you guys a couple questions, and I want to do a show of hands. I don't have a fancy poll where you can use your phone and scan the QR code, and we do some fancy cool stuff that I saw this morning. It was really cool, by the way. But I want to do a simple show of hands. Please show your hand if you recognize this situation, if you've ever been in a situation like this. Who of you has ever planned or worked in a sprint dedicated for bugs and technical debt? I know I have. Yeah, I guess that's about 80% of you. Oh, wow. Wow, that's a new one for me, but I love it. I love it. Thank you very much. Great. Whoa. Cool, cool. Another one. I have a few more, okay? There's a few good ones. Who's got items on their backlog that are created more than 12 months ago? That's everyone. That's everyone. Wow. Fantastic. And I'm guilty of that too, I gotta admit. Who recognizes this type of sprint backlog or sprint board? Where there's like a lot of work done, it's not no longer in process, but it's standing there for testing purposes, right? Anyone? All right, cool, cool. All right, yeah. Who looks at this at the end of the sprint, at the entire sprint backlog, and sees that about 20% or more of your issues in Jira or your items contain out of bugs, bug reports? All right. All right, two more. Who of you has cancelled retrospectives to finish the almost done work? Yeah, that's just messing with your reports, really. That's cheating, cutting corners. But I have to admit, I've done it myself as well. And the last one, oh, this is my favorite one. Product owners who do testing. You worked in a team where your product owner tests everything? Yeah, okay, cool. Is there anyone who didn't raise their hand during one of these questions? Okay, you may leave. This is no, that's a joke. Oh, it's just allowed. Okay, cool, cool, cool. Okay, so hopefully anyone can relate to these typical issues that we have with Agile stuff and Scrum and all the typical issues. And that's what this is about. There's, sorry, I have a bit of a cough. Excuse me. There's good news and there's bad news. So the bad news is I'm not going to be able to solve all of these issues today for each and every one of you. The good news is I think I have a few tools and a few experiences and approaches that I can share with you that you might want to pick up on and take home and try this Monday or this Tuesday, whenever you go back to work. All right? So first I'd like to address three major concepts that you're all familiar with, I know. But I want to redefine them, or at least make sure that we are on the same page, that we have the same sort of definition of it, so that from that point on we can move forwards to some strategies and understandings to handle and deal with those things. And the first one is bugs. We've talked about it already a little bit. What is a bug? To me, a bug is not something that is not working necessarily. It is something that we have delivered, that was working, that was defined in an earlier phase and now stopped working. And especially that stopping bit is very important in understanding bugs. Otherwise, typically anything can be a bug. An end user could report something he doesn't like or desires or behavior he didn't expect as a bug. So not necessarily all bug reports are bug. That's what I'm trying to say. I won't go into this all that into more depth, but it's a very important one to understand when thinking in ways of flow and how to increase flow. Another one that is fantastic, I love it, is actually my personal favorite, and this talk is not about that, unfortunately, but that's legacy. Now, who loves legacy? Okay, no one. So I'm the only one. No, I actually really like legacy stuff because legacy is a piece of history very often. It's actually interesting because through legacy we develop. If there was no legacy, we wouldn't have the great tools and technologies and frameworks we have today. So for that reason, I love legacy. However, dealing with it can be a bit of a pain in the You know what I was going to say with that. And you can recognize legacy typically, or actually I classify legacy based on three elements, three factors. And the first of them is a system, or yeah, let's say a system that predates the original team or the team that's working on it. There's no one in your company left that has maintained the system or was actively involved during the development phase. So that doesn't necessarily mean that if you have a team that works on a system and it develops it quite actively and there were no original members left, that's not what I mean. But there's currently no people with knowledge of the team, and it's almost unfamiliar to all of your employees. Another one, and that's more of a signal that you can pick up on to determine something legacy or not, is when you are afraid to touch it. Who is afraid of certain repositories that you know from your work that you preferably don't touch or not even clone? Yeah, you don't even want to clone them. You're afraid that you're going to break it. They're too complex. They're too dangerous, or at least you think so. That's a red flag there. That's a legacy flag. And as the last one, that is untested software. And I take this with a little bit of pragmatism, because I do not mean in this case that if you have like a 95% test coverage, that it's the 5% is legacy, the remaining 5%. That's not the case. But what I mean here to say is heavily untested software that could be determined as legacy. At least I see it that way, since testing is all about learning. And if there are no tests, we have no way of telling something about the quality of this system. So if you have an 80% coverage there, you're fine, I'd say. I cannot put a number on that. I cannot say it's like 30 or 50 or 60. But if it's heavily under-tested, you might consider that a legacy system. And you might want to learn about that. So let's move on to technical debt. My favorite. Test. Oh, there we are. Technical debt. Right. Oh, do I love technical debt? Actually, I don't, because there is no common way of dealing with it. It's very hard for teams dealing with technical debt if you don't have a plan. Who has a standardized plan? You can tell me right now, this is the way I deal with technical debt in my team. Who has an approach or document or something that you do on a daily basis? 1, 2, 3. Okay, cool. I hope by the end of this talk there's a few more, if I ask that question again. In technical debt, we typically have 4 types of technical debt, according to the theory of the quadrant. Let's go over that. Typically, we divide technical debt into 2 categories, and then we divide it again into 2, so it becomes a quadrant. And first of all, we have prudent or careful debt, careful decisions, and there's reckless decisions. There's like not so well informed decisions. And as I said, we can divide those 2 up again in deliberate and in accidental or inadvertent. So deliberate being on purpose. You could choose to take on technical debt. That could be a choice. That's the first one. The first one is a careful choice, but it's on purpose. Okay, so we take on technical debt. We know that we are aware of that fact, and we know that we're going to deal with it later. That's the one of the 3 people who just raised their hands. They're probably in that category. Then there's the same kind of choice. I mean, we deliberately take on technical debt, but in this case, we do it recklessly. There's not really a plan. We know that's technical debt, but we don't care about it. Okay? Don't be in that category. Then there is the accidental and careful decision. It's a careful decision, but we didn't know that we were doing it wrong. That we find out later. But later we do flag it as, okay, we shouldn't have done it that way. We should have done it differently. So we keep learning. And then there's the horrible one. It's the one that's where you're being reckless, but you don't even know about it. Yeah, don't be there, okay? That's typically how we could classify technical debt. Just to give you a bit of an example. All right. Who likes to take vacations? I do. I love it. More than work sometimes. This is pictures from my honeymoon. I went to South Africa. It was fantastic. I take any excuse to show these pictures. It has nothing to do with the rest of the talk, but I just want to put them on there. So you know that I was on a holiday to South Africa. We saw some black rhinos, really cool. And this is this, I believe what's called the Serpent's Pass or something into a country called Lesotho. That's a very high altitude country. And there's Drakensberg. It's a Dutch word actually. And here we are at sunset. It's fantastic. Has nothing to do with the talk. Now, it has a little bit to do with the talk. I've got an example of technical debt. It's a math example. Let's say you want to take a trip. I know for a fact I like taking trips. I like taking holidays because I can recharge my battery and start fresh again after a couple of weeks of absence, and I'm really charged. But in order to do so, I have to buy a trip, basically, right? And these things can get very expensive. It was the best trip of my life, but it was also the most expensive trip of my life. And that comes with decisions. Now let's say this trip costs a lot of money, so you got to save up. And in 1 year time, 12 months, I can save, hypothetically, a total amount of 2,400 euros in this case. I'm from the Netherlands. So I can save 2,400 euros a year, so that means 200 euros a month. And the total cost of this trip could be 6,000. Now, I have 2 children since that time, so it will probably now be double. But let's just, for argument's sake, say this is a 6,000 euro trip. Now, I'm a little short, as you can see. I can't afford this right now. I'm a little short. I need another 3,600 euros, okay? There's a couple ways I can handle this because I do want to go right now. I know for a fact I'm tired. I need to take a break. I need to charge my battery so that I can, perform as I want to. I could take on a debt. I could take on a loan at a bank or something, or a financial institution, or a relative perhaps, I don't know. I could take on a debt, and I need to pay that back in 1 year time. So after 1 year, you need to pay back the 3,600 bucks. We learned in a previous slide that I can save only 2,400. So at some point, I'm still short because I know I have to pay this back. Now, if you are the reckless, ignorant type, you don't care about any of this, and you haven't even made the calculation. I tend not to do that, or at least I try not to do that. So there's a few things you can do. At least you need to come up with a plan. That's if there's anything you learn from today, please, is when you take on technical debt, at least think of a plan. It might be a good plan or a poor plan, but at least think of a plan that's realistic. Now there are I know quite a few companies who have a lot of technical debt. Actually, I think all of them. We just established that. All of us. I'm guilty of that as well. And the most obvious strategy is to add more resources to the problem. Because if I add more resources, somehow, in the math example, I need another 1,200 bucks. So I could, for example, take on an extra job, doing extra hours, and pick up on some extra money. But does that make the problem go away? No, it doesn't. Actually, technical debt slows you down massively. So I worked for a company, and I know someone here who works for that company as well, so I won't name it, but there was quite a lot of technical debt, and they had an issue with bugs typically. So what they do is hire a test automation engineer to set up a test automation framework to get rid of the bugs. Well, if there's one thing I can tell you about test automation doesn't make you get rid of bugs. It helps you prevent bugs in production, and it's a lot of effort maintaining all that stuff. But they thought that was a proper solution, and yeah, well, sure, I like work, so you can hire me. I'm all for it. But actually, that wasn't the solution. The solution wasn't to hire the test automation engineer or consultant or whatever your problem is. You can hire them, but then still, have you faced the actual root cause of the issue? No, because bugs are a symptom of an issue. Bugs are never the issue itself. So you can add more resources to the problem, and what you'll find is that after that, at some point, you have to add more resources, and more and more. And that ball and chain will grow and grow and grow. At some point you see that teams, and I've seen this in Jira reports. I don't know if you look at annual reports of your team sometimes. You can see the amount of velocity that you have performed. And you see sometimes teams, when it goes down slightly but slowly. In January you took on 50 points, and by December you had a very successful sprint. You would call a sprint very successful if you only performed for 40 points, for example. Now, there's many reasons for that, and let's say that the team sticks the same the entire year, because that influenced that number. What you probably have done is you can add more developers to increase your velocity, and then you have the same problem. As I said, the ball and chain is growing. So adding more resources isn't necessarily facing the same as facing the issue, only when money is the root cause of your issue. If you, for example, have a greenfield project, I don't know, and you need to set up some infra, and that infra will cost you $500 a month, and you have only 250 available, then adding the other 250 will be a solution for your problem, okay? Because that's the cause of it. In means of performance and context of Scrum and velocity, adding more resources is actually never the solution. What you need to do is pick up that ball and chain, deal with it, and calculate. We just did the calculation before. I was $1,200 short. So there's a couple solutions. I said I could pick up another job if I really want to do it now, or I could just say no, I'm not doing it. I'm not downing my quality, because if I do that right now, I know for a fact that I cannot pay it back in the time that we need to pay it back. So you need to be either creative or just say no. And that's very hard for a business sometimes to understand. But it is required if you want to deal with technical debt. Another great example, and then we'll move on to more strategies on how to deal with it, is the vicious cycle of technical debt. And this is one from my experience as a test automation engineer. I see this happen a lot, and I bet some of you are guilty of that. You turn off your failing tests to make a build pass. Who has done that? Come on, guys, be honest. Yeah. I see shameless people just raising their hands. It's cool. Yeah, I know you do. And there's no harm in it if you turn them back on, if you fix them right away, if you take that issue, address that issue as quickly as possible. I can imagine that there's like a hot fix or something you need to deploy right now. And there's just one test, annoying little test that keeps failing, and you've tested it manually. You know it's a flaky test. If there's anything worse in the world of testing, it's flaky tests. So you turn that off. That's fine. I agree with that. You can do that. But then you need to fix that flaky test ASAP. And if you don't do that, you get this cycle. You get into a lower test coverage, and that doesn't necessarily introduce more bugs right away, but it will maybe in the long term. You get more bug reports, you get more hot fixes, more flaky tests failing, and we're back where we started. That's a big issue. So it's about a culture thing. If you accept technical debt, and that's what we accept here when we turn off the test to make the build pass, and we don't fix that issue. If you don't fix that issue, you're not paying back, and you're taking on technical debt that you didn't even know. Well, you might have known. You did know, actually. And there's many more different examples that we could sketch. I'm talking about failing tests, but we could do, you can imagine anything here. Cool. Let's talk about DevOps. DevOps teams are typically better in handling technical debt. You know why that is? Well, you know why that is. They are responsible for the entire software development lifecycle. Everyone has seen this image before, I'm sure of it. I'm not even going to ask. in a DevOps team, and I'm not talking about how we put these teams together and who is in that team, that's a whole different discussion. But in a DevOps team, typically we have a group of people, and we call them a team, and they are responsible for having all the know-how, all the knowledge, all the skills in getting this thing operational, both development and operational, okay? So we no longer have, well, we used to have separate teams, we put them together more or less, but it doesn't matter if you call them a team as long as they communicate with one another. That's most important. All the disciplines talking with each other, working with each other. And that's why they find it so annoying when there's technical debt, because they feel it right away. If you're a developer, if you're a programmer, you are also involved, and you get to see and get to talk with the people that, for example, find the bugs or see the bugs in production happening. You feel that pain a lot more. That's why I like it, because then if you feel the pain, you probably want to do something about it. Okay. All right, yeah. I've got a few sketches, really interesting sketches I found online I want to share with you. They're from a company called Devon, a Dutch and Indian DevOps consultancy, so I want to give them credit for the artwork. Early feedback over late feedback, typical DevOps principle. What is the earliest feedback we can get? Anyone? Has anyone an idea? Whoops. What's the most early feedback you get right now in your current setup, for example? Build errors, yeah, sure. Do you use unit tests as well? Yeah, a couple unit tests. Do you use unit tests in your pipelines solely? Okay, yeah. That's pretty early. If you have a build pipeline, after a commit or after a push, you run that pipeline, that gets run automatically. Fantastic. That's typical DevOps stuff. Get them as early as possible. You could even, run these unit tests in Git hooks locally as well. That might actually be not even more early. But I'm happy that you're doing that anyway, because that's good. There's a lot of people not doing that and having the late feedback. There's another big principle that, of course, I myself like a lot, and that's called automation over manual repetition. Who here has boring stuff to do sometimes? Boring stuff. Yeah, boring stuff. Do you think that can be automated technically? Yeah, I see a lot of people nodding their head. Cool. It's like a disco in here. Okay. That's a good start, actually. That's maybe a good item to put on your backlog. That's technical debt, probably. Maybe not bothering you that much, but it will speed you up if these exact items you can automate. Then there's the DOD. Everyone knows what it stands for? Definition of done. That on delivery. Yeah, thanks. That's Berwout. He's giving the opening keynote tomorrow, so clever guy. Thank you for the addition. That on delivery. Excuse me. So earlier we talked about this example with the borrowing money and stuff. Actually, the definition of done is like the bank that protects you from taking on too much debt. Last year I bought a house with my wife, and in order to do so, we had to get a mortgage. If you want to get a mortgage in my country, you typically go to a bank and you ask them, can you finance my house basically, and every month I will pay you a little bit of that debt and interest, a lot of interest. And what you need to do is they are going to run you through, really. They need to know everything about you, every little detail that has financial impact, your income, but also your expenses and everything. And they make a very proper, I hope, calculation on whether or not you are suited for a certain mortgage, for a certain amount, and whether or not they think you can pay that back. In software engineering, we don't typically have that unless you use your DoD. Now, who checks by default, who has it embedded in their process that the DoD gets always checked? One person. You're a good man. Yeah, tests are screaming if you don't. That's good. DoD could be more than just tests. Sorry. Who has stuff like documentation in their definition of done? Yeah, a lot of people. We've got like unit tests and stuff. Like, yeah, you got that. Cool, cool. End-to-end tests, perhaps, like the UI tests. And what do you have? Like, run them or update them, or yeah, both. Okay, good. Whew, that's good. Everything in your definition of done. I want to. This is one of those things you could do on Monday. Okay, go look at your definition of done. See what's not automated and what's the most boring. That's a good starting point to speeding up your entire process. Your team will thank you for it. Trust me. That's a good entry point. Oh yeah, this is a good one. Inbuilt quality over quality as an afterthought. No, that's actually an example of what I mean by the definition of done. You know, sometimes an image says more than 1,000 words. Now there's another interesting one. I once worked with a really good Scrum Master, really good Agile coach. Actually, the only one I've ever found good, to be honest. Sorry, am I insulting any Scrum Masters here? Are there Scrum Masters here? Oh, there's the one. Okay, two. Are there any product owners, dedicated product owners with no technical background? 0. Okay, that's good. So we can make jokes. Okay. Whew. I was scared for my security. You know. I worked as one Scrum Master, and typically, as I said, yeah, I have an opinion about Scrum Masters and the way they are. But this was a really good one, and I really wanted to work with him a lot longer. Unfortunately, I didn't get the chance to. But he had a saying, and it's a typical DevOps thought. He said, everything not yet given to an end user remains an untested hypothesis. What he meant to say is that once we have deployed something or put it on a staging environment or whatever, it's almost there. It's like we made the release notes and everything. It's just sitting right there, but it's an end user can't access it. Then it's still untested. The best test is giving it to the end user, because that's what we want. In Lean and in DevOps, we want to add value for that end user, for the user. That's who we're working for. We don't work for our business partner. We work for that end user. Now I realize in some branches it's impossible because you do not deploy to your end user. If you like, I don't know, make software for air traffic controllers, there's a lot of laws actually protecting that or blocking that flow, if you will, because flow is, you know, like no waiting and going to the end user really smoothly. So I know this is not always possible, but if it is possible, please deploy to your end user ASAP and don't do these really big releases. That's another thing in DevOps, and I know all of you have probably heard of this. Who of you works with deployment windows or release windows, like once a week or once a month or once a year? Okay, that's still a lot. Who of you can deploy and is allowed to deploy 10 times a day or more? Okay, so that's about half. That's the good half, though. Making things small, very key. Making things small makes it easier to deploy as well. It makes it easier to test, a little risk, and easier to roll back. And this is flow. That is flow. The big thing, that's not flow. That's the opposite. It's the anti-pattern. You know, that's what I was experiencing in this at the gate. You know, this really small room. Everyone's sitting there waiting way too long for their experience. And that's not really flow. Same thing I saw when we were having lunch earlier. It was like this massive line at some point. I got there early. I was lucky, so I didn't have to stand in line for. But I bet some of you had to stand in line for more than 20 minutes. Am I right? Yeah. Okay. Apparently you don't care if you stand in line for 20 minutes. That's okay. So that's flow. All right. Now we need to talk about. It's the last big aspect of decisions. In DevOps, there's a principle called data-driven decisions over gut feeling. Makes sense, really sensible stuff. But how do you do that? Now we're a bit short on time, and I do want to answer one or two questions, so I'm going to move on rather quickly, but I'll mention it anyway. There's 2 models in Lean that I've been using that are very effective and that make you help decisions, easy decisions, data-driven. They're called the AHP metric and then the Pew metrics, and they are complementary to one another. With the AHP metric, you see an example right here we define how important we find properties of a certain decision. Let's say, in this example, we are, I don't know, what are we deciding? We're deciding on what solution is the best. We have a couple solutions listed up, but before we can go look at the solutions, we need to decide what properties do we find most important. And if you can see how you do this, it's actually a team exercise, so you should do this with the entire team. Only the green cells are the ones you have to fill in, and the other ones will be filled in automatically. You start at the top left, you see performance, and you check what is more important, performance, and then you go up, or performance. Now the first one is grayed out because you can't compare the same thing with itself, but you can compare it with the second one. So we care what's more important, performance or security. Apparently we choose performance. I don't know why, but okay. Sure, and you give it in this case a 9. That means this cell gets auto-filled with 1 versus 9, or 1 divided by 9, so the exact opposite. And you keep working this row. Once you're done, you move to the second row. You start with security versus usability. Apparently in this case we find usability more important, and etc, etc, etc. Then you add those together. It's a sum of each row. That will be the weight of the property for the decision model. This is the decision model, the Pew matrix, where we have the weight that was calculated from that the sum from what we just did in the AHP metric. And then we have 3 solutions. We take one baseline. That could be either one of the solutions you come up with. If you need to pick a framework for a new website, it could be, I don't know, the current solution probably, if you have that, or it could be one of the many solutions. And that gets only zeros. That's the baseline. And then we compare every solution with the baseline. So we say solution 1 versus solution 3 on performance, who does better? Well, they're quite equally in this case, so we give it a 0, or a 1, or a 2, or -1, -2 in case. And then there's a sum, and in this case, as you can see, solution 2 is the clear winner, and that's a data-driven decision. Go look that up, please. AHP Pew matrix, really, really powerful decision tool. Another thing I want to show you, I want to tell you, is a principle that is called decide as late as possible. I think it's really well illustrated in this picture. Don't do this in real life though. This guy, he apparently takes the exit at the very, very last second. And what I'm trying to say is, when there is a decision to be made, ask yourselves if you are in doubt, if the decision is not clear, the solution is not clear. Do I need to decide today? Your Scrum Master will say you do, because he wants the burn down chart to be really straight and stuff. Don't listen to the Scrum Master. If you don't need to decide today, if postponing the decision doesn't hurt anyone, and there is time to get extra information in between now and your deadline, really, then go for that extra information. Make sure that you get the most informed decision you can possibly make. Decide as late as possible. Now, I've applied that, I've seen that in a few teams, and what some developers tend to do is then stick with that research phase, really. There's this, I was in a team once where they worked on a PHP project, and they wanted to check a framework, if it was good enough for the purposes we wanted to do, and they want to embed another framework, and it was a whole very complex thing, and they could go on and on in the research phase, in the proof of concept phase. They could endlessly learn about this possible solution and never stop and never get done. At some point you have to call it a day, okay? So there's also good is good enough. If you have proven what you want to prove with a proof of concept, if you have found the fundamentals of your research, then stop it. Good is good enough. Once said by a very smart man. Well, here's another one. Good is not good. Yeah, good enough over total conformance. Conformance. Okay, I don't know how to pronounce that word. Sorry. I'm almost done. I want to illustrate this by telling one more story. Yeah, good is good enough. Stop. The point is stop analyzing old data at some point. Yeah, it's a personal story. It dates back about wait, there it is. It's a personal story. It dates back about 10 years ago. 10 years ago, I was in the army, in the Dutch army. And sorry, this is a personal story. It's a bit, I've never told it in public before, but I will to demonstrate this point. I was in the army, and in the weekends I was doing music. I'm a musician. I play bagpipes, Scottish bagpipes, and in the weekends I was very busy performing and doing gigs. And this one night I came home and I was parking my car around the corner, and I was locking up my car, and someone walks up to me, and he attacked me basically. He stroked me from behind, and when I turn around, I see that he's holding a knife and he's really going at it. And stuff went black, really. I couldn't remember a lot of that, what happened. I did now, but couldn't back then. There was a little bit of a fight. It was very ugly. I got out alive. I'm all right, really. I passed out during that fight somehow. I hit my head on the floor, and when I woke up, my wallet was gone. That wasn't a bad thing. I wouldn't have cared. And I called the police, and everything was. I was stitched up. It was all fine. And I wasn't really fine mentally. The first couple of weeks I was, but I wasn't really fine mentally after that. I struggled with some PTSD symptoms, and luckily I was in the army at that point, because they have specialists who can help you with that, and they did. And I can say honestly, I'm really fine today. But it took quite a while, and the reason why is that I couldn't stop analyzing what happened. I couldn't make sense of this situation, because if you list up all the events that happened that night, someone attacking you without a warning, and then taking your money, but also hitting you, cutting you with a knife, that doesn't make sense. I hope you you guys don't know how to knife fight, but this guy, he was striking me instead of stabbing me. And I know some guys who are skilled knife fighters, that's not how you fight a knife. So if that person really wanted me dead or wanted to injure me, he should have done it differently, or he would have done it differently. And if he really was after my money, what he took, he would have asked for it probably. It would be a mugging. You know, when you mug someone. I've never done that, and I will never. And I hope you guys aren't either. But if someone gets mugged, typically someone asks you for your money or says what he or she wants. That didn't happen either. Nothing about that event made sense. And I still cannot make sense of that. But it doesn't matter. At some point you have to move on. That's what I'm trying to say. Forget about it. You will never be able to forget about something like that. But stop mulling it over. Stop analyzing stuff. There's no new facts coming in. Nothing is going to change about the data that you have, the data that I had. I went through therapy. That's fine. I could remember some more stuff, but it still wouldn't matter because nothing made sense. So I set that aside. All right, that's a fact that it doesn't make sense, and I get to move on. And that's what I wanted to tell you. Stop analyzing old data and just move on at some point. Don't over-engineer your stuff. Just go for it. If it's good enough. Deploy it. Give it to your end user. He'll be happy with it. So when you go home, I hope you remember a couple things. Please don't take debt without a plan. Said it before. And a good plan, preferably. Make a calculation. Make sure that you know what you need to pay back and how you're going to do that. Another great tip, technical debt goes to the top of the backlog. That's a bit of a controversial statement, but I've applied that, and if you at some point have a acceptable amount of technical debt, this is what you do every sprint. Every sprint there's technical debt issues at the top of my sprint backlog, and I get to work on it. I don't do the entire backlog. Every sprint there is technical debt. Start automating boring stuff or DoD stuff. It's typically a good starting point. Look what you want to be done that you find boring and ugly and you don't want to do and you forget, and that's the typical ones. And then again, make data-driven decisions. Apply the AHP metric and the Pew metric. Look that up. I will put these slides on GitHub, and you can check that out as well. But look the AHP and the Pew metric up. It's really easy tool, really cool exercise to do with your team, and you'll make fast and data-driven decisions. I want to take one question. I think we're almost done. But is there anyone who wants to ask a question? I know I've been saying very general stuff. It's not one size fits all. But maybe there's one who has a question.